Here we are on page 6 dealing with right triangles and similarity. Number 1, fill in the missing values of the Pythagorean triples. So this is fitting a squared plus b squared equals c squared, and obviously c is the biggest one. That comes from a little right triangle like this where you have an a, a b, and a c, and it is definitely in a right triangle. So let's look at these and see what we have. So here we have 3 squared plus 4 squared equals, well, 9 plus 16 is 25 square root, so this guy is a 5. Okay, 5, 12, so we get 5 squared plus b squared equals 13 squared. This is 169, and we're going to subtract off that 25, and that'll give us the b squared. 169 minus 25 is 144, so b has to be 12. All right, 12 blank 20, so 12 squared plus b squared equals 20 squared. 400 minus 144, that's b squared, is going to be a 256. Square root that and we get a 16. Special numbers that work here, so some of these you might want to start recognizing because a Pythagorean triple is kind of a special deal. Special 3 numbers that fit that pattern. So a squared plus 15 squared equals 17 squared. You can do this on your calculator, but 289 minus 225, and we get a squared equals 64. So a is going to equal an 8 in this one right here. Okay, 724 blank. So 7 squared plus 24 squared equals c squared. This is 49 plus 576, I think is what that one is. 49 plus 576 is a 625 to equal c squared. Square root that and you get 25. Yes, all of these were designed so that they came out to be even. Doesn't always happen with numbers, and we might get some square roots, which we'll have down in here. Okay, so 16 squared plus blank squared equals 34 squared. 16 squared plus b squared equals 34 squared. So 34 squared, I'm starting to get up to where I might need this a little bit. 34 squared, and we minus 16 squared, and that is 900. If we square root that guy, oh, that looks like it'll come out nice as a 30. So square root of the answer, and yeah, we get 30. So this guy is going to be a 30. Now I would like to show you something that may be, that's 900, and then b was 30. So we should note that this guy right here is exactly double the size of this guy. 8, 15, 17 is a triple that works. If you just expand that triangle by a factor of 2, you now get 16, 30, and 34. The same thing happened here. We took a 3, 4, 5 triangle, and if you times everything by 4, you get a 12, 16, 20 triangle. And that's true. Any multiples of Pythagorean triples have to be Pythagorean triples in and of themselves. Okay, so this one, 60 and 61, yeah, we're not going to be multiples of that, but I thought it would be a good connection to bring up there. So the next one, blank 60, 61. So that's a squared plus 60 squared equals 61 squared. Oh boy, those are going to be big. So we're going to take 61 squared minus 60 squared, and that equals 121. Oh, so that's an 11 right there. Indeed, indeed. So the next one, 21 blank 221. So a squared 21 squared plus b squared equals 221 squared. Alrighty, so we're going to take 221 squared minus the 21 squared, and that equals a big number, and square root that puppy. And we get 220. That guy's 220. So there we go. Now this is very interesting. You'll notice this guy right here, 220 and 221, that these two right here next to each other, and so are 60 and 61. Whenever you have two numbers, consecutive numbers that add up to a perfect square of an odd, then that will always form a Pythagorean triple. Very interesting little connection there. Okay, let's clear this off and start on 2 through 7. All right, number 2. This 2, 3, and 4 have this shape right here, and these are parallel lines, so we get that this is the same angle, and that that guy is the same as that guy, and this guy down here is going to be the same as that one. So we have similar triangles, and notice that we'll be able to do A is to X as C is to Y as well. So number 2, so we have A is 5, B is 10, and C is 7. So X is 3, so we get A is to X, 5 is to 3, as C is to Z. So 7 is to Z. All right, so 5 is to 3 is 7 is to Z. That's by these parallel lines here. And so we get 5Z equals 21. And then, this is number 2. Let's put that up there. And 5Z equals 21. Z equals 21 fifths, or 4.2. So Z is 4.2. Now it's a little bit different on the Y. We have to be careful. We can't go A is to X as B is to Y. That doesn't quite work. We have to do 5 is to the whole side of the triangle. 5 is to 8 as B, 10 is to Y. So we get 5Y equals 80 and divide by 5. So we get Y equals 16. So Y equals 16. There we go. Okay, number 3. Let's put this one right down here. Now we have the X and the Y and the Z. So, and we have a B. So Y is to B, so 9 is to 6, as A plus X is to A. So A plus 4 is to A. Ooh, that's a little bit tougher one, but we can still do it. Can you see that? We did the big triangle to the little triangle in both of those. So if we multiply through, we get 9A equals 6A plus 24. That's multiplying through both sides by a 6A. Then we subtract 6A and we get 3A equals 24. So A equals 8. A is 8 right there. Good. Now we can use the parallel lines to get A is to X as C is to Y. Now notice that's not just little triangle to big triangle, and really in slow motion this is what it really looks like. Big triangle is to little triangle as big triangle C plus Z is to little triangle. And notice if you break this apart, this is A over A plus X over A equals Z over C plus C over C. This is a 1, and that's a 1. So this is where we get this ratio with the parallel lines in it. So we can do 8 is to 4, that's A is to X, as C is to Z, 5. So many of you can say that's going to be a 10, but let's do it anyway. Times by 5, and you get 40 over 4 equals C. C equals 10. So C indeed is a 10. All right, last one on this set. 4 gives us, let me see, we have a B is to Y. That's good. That's good. So we can do B is to Y. So that's 12 is to 20. So we'll put this down here. Big triangle to little triangle. 20 is to 12, as big triangle C plus Z is to little triangle. Oh, yeah, that worked. That worked. So multiply through by 11 times 12, and you get this cross multiplication thing. So you get 220 equals 132 plus 12Z. Subtract 132 over there, and we get 12Z equals 220 minus 132 equals 88. So divide by 12 and divide by 12, and Z is going to equal, looks like 7/3. 12 goes into 88 7 times at 7.3 repeater. So that's what we get there, 7.3. All right, and the last one right here, we're going to do 20 is to 12. Let's do it to find A. 20 is to 12. That's the big triangle to the little triangle, is a plus 7 is to 7. So we get 12a plus 84 equals 140. Subtract 84 over there and we get 56. So 12a equals 56. And divide by 12, divide by 12. And we get a equals 12 goes into 56 4 times with the remainder 8, so 4.6 repeater. So there we have it, 4.6 repeater. All right, let's erase this off so we have some room for 5, 6, and 7. All right, before we begin, we better make sure we know what this picture is really saying. Right here, we have 3 different triangles. When you draw an altitude in a right triangle, you get certainly the big triangle ABC. But notice that we also have this angle right here that we can designate, and this angle up here. Now the blue and the red ones are complementary. They're in this big right triangle. So notice what happens is that this blue one right here means blue 90 degree. This guy has to be the same as that angle up there, which means that this guy right here has to be the same as that angle. So we have 3 triangles that are 90, and then the blue one, and then the red one. Let's see if we can break these out and see what's happening. So the big triangle, the easiest one to see, looks like this. And you have the A and the B and the C. And of course it does do a squared plus b squared equals c squared. Now if we look at the BYZ triangle, so I'm going to write it out like this. It's going to be a little bit smaller. This is Y, this is B, and this is Z. Let's see what exactly happened here. I took this blue angle that's right down here and I kept it in the same place. But I took the Y and the B and kind of cranked them around so this red angle showed up here at the top. So it would mimic this red angle. And then the 90 degree that was up here in the corner came down to the bottom. So I just took that out, grabbed my hand around here and flipped it around so that it would mimic this right here. And notice we have similar triangles. We're going to do that with this other one as well. So I'm going to write this smallest one right over here and see where those angles mean. So here I'm keeping the red angle right up where it stays, right there. And I'm switching the other stuff around. So this blue angle right here flips over here, and this 90 degree is the one that flips down here. So let's see what sides we have. So this X came down to where the A is. The A is the hypotenuse, and the thing across from the blue angle, yep, it was the X. The thing across from the red angle is the Z. So this guy, I grabbed the X and the A and cranked them around. And this one, I grabbed the Y and the B and cranked them around. So we can kind of see what happens. Notice we can go A is to Z as B is to Y, or A is to X as B is to Z, or C is to A as A is to X. We can do a whole bunch of proportions there. So when we do this, we're going to use these pictures to draw the proportions in 5, 6, and 7. So let's do number 5. In 5, we have A is 5 and B is 12. And then we don't know anything else. Well, we do know we can finish out this triangle right here by, hey, we did this before, a 5, 12, 13. 5 squared plus 12 squared, C has got to be 13. So let's put that guy in there. Now let's see if we can find any of the X's, Y's, or Z's. So we could go, here's A, B, and C. Notice that the B here is a 12, and the C, we already know, the A is a 5. Oh yeah, so look, we have proportions that we can draw everywhere. Z is to 5 as 12 is to 13. Z is to 5 as 12 is to 13. So that's 13Z equals 60 by the multiplication, cross multiplication here. Divide by 13 and we get Z equals 60 thirteenths. It's not really a happy looking thing, but we can do it. All right, let's do something that'll find the Y's. Yeah, Y is to 12 as 12 is to 13. Y is to 12 as 12 is to 13. So we get 13Y equals 144. Ooh. And then Y equals 144 thirteenths. All right, so that's what y is, 144. Oh, that's going to get pretty tight in there, 144 thirteenths. Now we got to find x. We can go 5 is to x as 13 is to 5. 5 is to x as 13 is to 5. So we get times the 5 up here, times the x up there, and x equals 25 thirteenths. Cool. So that was number 5. Let's clear that off and look at number 6. All right, number 6. We have a equals 5 and x equals 3. That doesn't give us very much at all. But we can go, oh, there's our 5 right up there. Okay, so there we've got at least something here. We've got one of these triangles we can do. 3 and a 5. Look at what z is. Z, we know from this guy, is a 4. Oh, that's good. Let's put that z as 4. Good. So then we have z is 4. And so we can now do, oh yeah, look at this. 3 is to 5 as 4 is to b. 3 is to 5 as 4 is to b. Equal sign there. So we get 3b equals 20. B equals 20 thirds. All right, let's put that in, 20 thirds. All right, let's find something that we can do c. 3 is to 5 as 5 is to c. 3 is to 5 as 5 is to c. So we get 3c equals 25. C is 25 thirds. Good, look at that, 25 thirds. And now all we need is to find the y. Oh, how can we do this? We'll have to do something a little bit. Oh, we know z is 4. I should put that guy in right there. So 3 is to 4 as 4 is to y. So we get 3y equals 16, and y is 16 thirds. Excellent. Excellent. Good, good, good. Okay, let's clear that off and do number 7. All right, now with number 7, we know that x is 3 and y is 12. Oh boy. Hey, that means that c is a 15. That gives us a little bit of stuff. But that's not totally everything we need. Ooh, we don't get a full triangle anywhere, so we really have to think about some of these proportions. I mean, if we did 15 is to a, we could do as b is to z. That wouldn't work. But oh, hey, look at this. 15 is to a as a is to 3. Look at what we get here. That even though we don't know these two values, they're the same ones. So when we cross multiply, we get 45 equals a squared. We can solve that for a. A is going to be the square root of 45. That's okay. It's a square root. It's the right number. So we get, can that be simplified? That's the square root of 9 times 5, and the square root of 9 is 3. So a equals 3 square roots of 5. Oh, we better put that in somewhere. 3 square roots of 5. And a is 3 square roots of 5. Oh, I wonder if we can do that again with this. Z is to 3 as 12 is, yes, we can. 3 is to z as z is to 12. 3, yeah, we get 36 equals z squared. Hey, this one comes out nice. Z is a 6. Oh, that's pretty cool. Now I want you to notice something a little bit about this. When this proportion 3 is to z is to 12, 3 is half of 6, and 6 is half of 12. There's a common ratio from 3 up to z and z up to 12, and that's, you know, you times by 2 and you times by 2 and you get it. Yeah, so 6 is kind of in the middle of 3 and 12 in that sense. X, z, and then y. That's kind of cool. All right, let's see if we can get c now. Oh, we already knew c. It was 15. All righty, that's good. All right, let's clear it off and move on to number 8. With number 8, find Find the arithmetic mean and the geometric mean. So arithmetic mean is to take the two numbers like 2 plus 18 and divide by 2. That's 20 divided by 2 is 10. The geometric mean is where you take 2 times 18 and then you square root. And you get the number. There's 2 times 18 is 36. Divided by square rooting it, you get 6. Now let's make sure we understand what that is. When you take 2 and 18 and you put 10 in the middle, you've just created an arithmetic sequence where you have a step of 8 and a step of 8. That's how that guy's in the middle. A geometric mean, when you take 2 and 6 and 18, notice it's not in the middle by addition and subtraction. It's in the middle by, when you times by 3, you'll get 6, and when you times by 3, you'll get 18. It's very interesting. Z is the arithmetic mean of x and y. Notice that we would do x is to z as z is to y. This ratio to up to z and that ratio up to y are the same, or in other words, xy equals z squared. So this is where we get the idea of the square rooting of the two things multiplied together. If we had a 2 here and an 18 there, this guy would be a 6. And I think that's what we did in number 7. We had a 3 and a 12, and 3 times 12 was 36 square root. So this becomes a geometric mean in a picture of what's going on. But it turns out that we have now created a geometric sequence, which is one that has a common ratio, and this is the guy in the middle of 2 and 18. Okay, with that background, let's move on and see if we can do the other ones. 5 plus 20 divided by 5 plus 20 divided by 2, that's the arithmetic mean, and the geometric mean. 5 times 20 is 100, square root is 10. And yeah, that'll be right in the middle. 5 up to 10 is a factor of 2, and 10 up to 20 is a factor of 2. All right, 4 plus 9 is 13 divided by 2, so 13 halves, or 6.5, is the arithmetic mean. And 4 times 9 is 36, square root is 6. That's the geometric mean. 5 plus 11 is 16, divided by 2 is 8. That's the arithmetic mean. 5 times 11 is 55. Square root is the square root of 55. That one didn't turn out to be really cool. 7 plus 14 is 21. Divided by 2, that's the arithmetic mean. And 7 times 14 is 98. And the square root of 98. Oh, that doesn't turn out to be very nice at all, but let's see if we can simplify that at all. Square root of 98. I'm going to break it down. That's 2 and 49. Square root of 49 times 2. Look at that. We found a perfect square. What's the square root of 49? 7. 7 square roots of 2. Okay, so that's important. That if we took 7 square roots of 2, and then 14, because we found this as a geometric mean, there's a common ratio that if you times 7 by a certain number, you get this one. And it looks like that certain number is the square root of 2. So if we take 7 square roots of 2 times the square root of 2, do we really get 14? You can try that in your calculator. We should do that just so we see it's in there. 7 times the square root of 2. And we take that number and we times it by the square root of 2, do we really get 14? Wow, math is true. That's amazing. So yeah, 7 times the square root of 2 times 7 square roots of 2, that's 7 times the square root of 2 times square root of 2, that's the square root of 4. That's 7 times 2, that's 14. Yeah, that is the geometric mean of those two. All right, let's try this one. 2, oh, this is going to take a little work. 2 plus 8/9, all divided by 2. So that's 18/9 plus 8/9. That's 26/9. All divided by 2 gives us 13/9. Okay, that's the arithmetic mean. Yuck. Okay, and 2 times 8/9, and then we're going to square root it. So that is 16/9. Underneath the square root sign, that is 4/3. Hey, that came out nice at least. Wow, look at that. That is arithmetic means and geometric means. Let's get some of our work out of the way here, and we'll go on to these 40, 30, 60, 90 triangles. All right, as a review, 30, 60, 90 triangles. have this pattern always on them, that if this side is 2, this side, the 60 degree here, this side would be 1, exactly half as big, and this side is the square root of 3. And that comes because this is half of an equilateral triangle, so this side would have been 2 down here that we cut in half. And then a squared plus b squared equals c squared, we get this square root of 3. And we're going to leave them exact. And the 45-45-90 triangle is a square cut in half. So this is a 45. If this is 1, then that's the other side of the square. And 1 squared plus 1 squared, square root of, gets the square root of 2. So make sure we don't get things confused between the two, and we'll try to do it. So number 9, we have the triangle where alpha is 60. So if we do this guy right up here like that with a 60 there, and a is 5, that means b is 5 square roots of 3, right? So we times by the square root of 3, we get 5 square roots of 3, and c is 10. And theta is your 30 degrees. Good. Now we go with number 10, and we're going to have C is 30. So we've got this triangle right here, and this is 30, and theta is 30 degrees. So that's 30, and that must mean that's 60, obviously. Good. And so we've got half of 30 is the short side, so that's 15 at A. And b is the long side, which is 15 times the square root of 3. Good. So that's the pattern. The shortest side, the side across from the 30, is half of the hypotenuse. And then it's timesing the square root of 3 up here. So 11, let's try this guy. So number 11 comes out here, and we've got, let me draw the triangle for number 11. And we have a, beta. We're doing this guy. So let's redraw that triangle. We are doing a 45-45-90 triangle out here with number 11. So beta is 45, and then x is 1, so y is going to be 1, and z is going to be the square root of 2. 1 and the square root of 2, good. And then the gamma is 45 degrees. Oh, this is nice. Number 12, here we've got a new one, and so it says if x is 3, y is 3, z is 3 times that square root of 2, so we get 3 square roots of 2 there. And then if gamma is 45, beta is 45. That's it. All right, good. Number 13. Number 13 has a one that's going to be looking like this. It says theta is 30, so we're in a 30, 60, 90. Good, so that gives us 60 up there. And it says that b is 7. Ooh, that's a tough one. They gave us the long side. So we've got to divide by the square root of 3. So a is 7 divided by the square root of 3. We don't leave square roots on the bottom. We got to times by the square root of 3 on the top and the bottom, not changing the number but making it look different. So we've got 7 square roots of 3 over 3. All right, that's what a is, 7 square roots of 3 over 3. And c is exactly double a, so that's 14 square roots of 3 over 3. Good. Number 14. Ooh, this one looks kind of not nice at all. I'm going to have to draw a big one for him. So it says that alpha is 60. Good. That means theta is going to be 30. That was a nice easy one. I like that. We're in 30, 60, 90 triangles. But it says a is 5 square roots of 11. So to get to the hypotenuse, we have to double it. So that's nice. 10 square roots of 11. To get to the long side, we have to times by the square root of 3. So that's 5 square roots of 33. Yep, there we go. All right, number 15. Number 15, we've got a 45, 45, 90 triangle. So we're at a 45, 45. Good, that was easy. So y is 3 square roots of 7. Well, y and x have to be the same size because we're in a 45, 45, 90 triangle. So 3 square roots of 7 there. 3 square roots of 7. And z is this times the square root of 2. So we get 3 square roots of 14. Excellent, excellent. All right, number 16. Let's do this guy. So we've got a 45, 45, 90 triangle. That's what these guys say. Z is length 5. Oh, this one's tough because we've got 5 and we've got to divide by the square root of 2 to get down to this one. So 5 divided by the square root of 2. We don't leave square roots on the bottom, so we times by the square root of 2 over the square root of 2, and we get 5 square roots of 2 over 2. And that works for x and y because it's an isosceles triangle. Excellent. Now we're down to number 17. Okay, number 17. Let's see what we get here. We have 60 degrees here. That means we've got 30 degrees here. Oh, that's a nice one. And C is 2 square roots of 5. Oh, so they gave us the hypotenuse. So in order to get to the short side, we have to cut it in half, which makes it square root of 5 for A. And in order to get to the long side, we have to times that by the square root of 3. So we get the square root of 15. Huh, alrighty. The next one, number 18. Let's draw it out here so we can see it a little bit. It says that theta is 30 degrees. That's good. Alpha is 60 degrees here. That's good. And we have the hypotenuse as 1. So we got to divide by 2. We get 1/2. And times by the square root of 3, we get square root of 3 over 2. So this gives us A is 1/2 and B is square root of 3 over 2. Just that times the square root of 3. Alrighty. Oh, and alpha, of course, is 60. All right, 19. We're back in this 45, 45, 90 triangle. So we've got a 45 here, 45 there. Oh, let's write that guy down. Now, 10 square roots of 6 on the Z. Okay, so to get back down to there, we got to divide by the square root of 2. So that's 5. Nope. That is 10 square roots of 3 and 10 square roots of 3. Okay, that wasn't too bad. 10 square roots of 3. Good. Okay, number 20. Let's draw this one out. It says that Z is 1, and we're at a 45, 45, 90 triangle. So we get to divide by the square root of 2. 1 divided by the square root of 2, we get the square root of 2 over 2. Square root of 2 over 2, square root of 2 over 2. So we have these. I need to draw these out. We're done with all the problems, but let's make sure we see what we have. In a 30, 60, 90 triangle, where the hypotenuse is 1, this is 1/2 and square root of 3 over 2. In a 45, 45, 90 triangle, where we have the hypotenuse 1, it's the square root of 2 over 2 and the square root of 2 over 2. So these numbers come up a ton in the future, especially in trigonometry.